Today we're going to talk about the internet and the World Wide Web. Okay, but we're going to start by answering a few recall to retain questions. Okay, so what we've got here is the question says the only time the output will be 1 is when both inputs are 0. Okay, so we're looking for a situation, and I'll just draw the truth table. Okay, so we're looking for a situation where our truth table is 0 when our truth table so the output from our truth table will be 1 is when both inputs are 0, so it'll be 1 0 0 0. Okay, so what gate does that match? Well, that's the opposite of an OR gate, so in fact it is a NOR gate. Okay, and if we just draw a NOR gate, what does a NOR gate look like? Well, it's exactly the same as a OR gate, but just put a circle in front of it to signify that it's a NOR gate. Okay, so we'll just move on to the next slide. Okay, so in this slide, okay, what we're trying to do this time in this question is the only time the output will be 0 is when both inputs are 1. So again, if we create the truth table for that, okay, it says the only time the output will be 0 is when both inputs are 1. So that'll be 1 1 1 0, and if we look at that, that's the opposite of an AND gate. Okay, so what we need to draw here is a NAND gate. The opposite of a AND gate is a NAND gate. Okay, and if we draw a NAND gate again, it's exactly the same as an AND gate, just with the little circle up front. Okay, and we'll move on. We've got a question here about optical storage. Okay, so what we need to do is we need to give 3 different examples of optical storage. Okay, well, let's start. Why don't we start with a CD-ROM? Okay, so that's the smallest capacity of optical storage. Then we can move up to a DVD. Okay, which can store what, 4.7 gigabytes. Okay, and then we can move up to the biggest capacity optical storage, which is of course a Blu-ray drive, a Blu-ray. Okay, so those are our 3 examples of optical storage. Okay, final question then is just asking us about inserting the missing terms, and this is all to do with different types of language and the generations of language. Okay, so if we have a read, and we'll do it together, the structure of language statements in the computer program is called the syntax. Okay, so we're looking for the word syntax here. A programming language that uses natural language statements is called a high-level language. Okay, so it's a high-level language because it is very much similar to English. Okay, when programs are written in this type of language, they need a. So when we write programs in a high-level language, we need a translator. Okay, so that the computer can understand them. Okay, and we translate them into to convert them into machine code. Okay, so our translator converts our high-level language into machine code. All right, and then the final question, we've got 2 more spaces. It says a programming language that's written using mnemonic codes is called. Now, a mnemonic is defined as something that helps us remember. Okay, so obviously we talked about machine code being very difficult to remember, all those binary codes. Okay, so someone invented assembly, which just gives each of those binary codes a little mnemonic, making it easy to remember. Okay, so what we're looking for there, the programming language that uses mnemonic codes is called assembly language. Okay, and this is an example of a low-level language. Okay, it's an example of a low-level language. Alright, so those are our recall to retain questions complete. We're now going to move on, and what we're going to do is talk about the structure of the internet today. Okay, so what you can see on the slide that I've got here, okay, is a trace route. So I've done a trace route, and all I've done is I've typed in trace route into the terminal, okay, and then I put where I want to trace the route to. So I put trace route space, and then I've gone to www.google.com. You can pick any URL that you prefer, okay, any website that you like. Okay, and what this shows, okay, what we can see here, this one here is me, this is my home. Okay, and this shows the journey that data takes to get to google.com, which is all the way down here. Okay, so what I'm asking us, and what we'll understand hopefully a bit more about by the time we get to the end of this video, okay, is what's going on here. Why do we see these different steps? Okay, we're going to find out about the structure of the internet so we can understand the journey that data takes to get from my house to Google. Okay, let's move on. Okay, so I think the best way for me to explain how this works is to give you an analogy. Okay, so I want you to think about going home. So a lot of us are from the UK, or wherever we're from. I'm from the UK, so I'm going to think about getting back to the UK. So I'm going to think about travelling from where we are here in Houston back to the UK. Okay, and I want you to think about that as we talk about this. Okay, so I'm going to start by getting a taxi from my house to the local bus station. Okay, so I get a taxi to the bus station. Okay, now what I want you to consider is when I get to the bus station, okay, is the airport the only place I can get to from there? No. Okay, actually what happens is I can get to lots of other places from the bus station. Okay, I can get to other bus stations, alright, and I can get to other stops on the way. Okay, so the bus station is a bit like a hub which lots of places are connected to. Okay, and so hopefully you see that in my diagram. Okay, now when I get to the bus station, what I'm going to do is obviously I'm going to take the bus to the airport. So I'm going to take this route here to get to the airport. But there's lots, as I said, there's lots of other buses I could take to get to other places. Okay, and I want to keep that in mind. Okay, so I take the bus to the airport. Now, just like the bus station, when I get to the airport is another hub, isn't it? Okay, because when I get to the airport, there are lots and lots of other places that I can visit. Okay, not just the UK. So I can, I can fly internally, domestically. I can fly internationally. I can fly to Southeast Asia. I can fly to Europe. All right, there are lots and lots of different places that I can fly from the airport. Okay, so that's another hub, isn't it? Okay, and again, so we've got this kind of hierarchy of hubs. We've had the bus station, and then we've gone from the bus station to the airport, and that the airport is another hub. Well, with lots of different places connected to. Okay, so when I get to the airport, of course, what I do is I take my flight, and I'm going to fly to the UK. Okay, hopefully that makes sense. And of course, when I get to the UK, so it's what, 10-hour flight. I've arrived in the UK, and I've arrived at another airport, which is another hub. Okay, and again, remember, from the airport, I can get to lots and lots and lots and lots of different places. Okay, obviously I want to get to my house, but I can get to lots of other places from the airport. Okay, so the airport, the airport in the UK, Heathrow, is another hub connected to lots and lots of other places. Okay, so from the airport, I am then going to get a train. Okay, so I'm going to get a train from the airport. Okay, so I'm going to be at the so like the train station is another hub, isn't it? Okay, and obviously from the train station, okay, I can get to lots and lots of other places when I'm at the train station. Okay, so I'm going to get a train from the train station. Okay, and then when I get to the train station, when I arrive at my at the station of the town I live in, I'm then going to get another bus. Okay, but so what we've done is, if you have a look at the diagram on the slide, okay, is hopefully what you see is that we have travelled from Houston all the way to the UK, but we've done that by travelling through a series of hubs. Okay, and so what we've done is we've travelled through a series of networks. Okay, and we can draw it in a slightly different way. So we had this, we had the bus station at the bottom, which was connected to lots of things, lots of places that the bus station was connected to, and then from the bus station we went to the airport. Okay, and obviously the airport was connected to lots of things, not just the bus station. Okay, and then from the airport we went to another airport which was connected to lots of things. So we've got this kind of hierarchy of networks. Okay, and in fact what's really important to understand is that the internet is actually just a series of networks. Okay, and the definition of the internet is a network of networks. Okay, now look, what's really always amazes me about what we've just talked about, okay, is the fact that the journey that I've just described to you to go from to go from Houston to the UK, all right, takes roughly about 14 hours if I'm going to get to my home in the UK, okay. But actually, a piece of data can travel across the internet in less than a second. Right, so the speed at which that data is traveling is just unbelievable. Okay. So hopefully, what we now understand is that what we're seeing in this diagram, okay, in this trace route that I've done, all right, is you are seeing the steps that the data is taking, the networks that the data is traveling through. Okay, so it's going from my home network, all right, and then you will see some of these IP addresses will look quite similar. Okay, so you know, this is my ISP. This is like Comcast. Okay, then maybe it goes outside of Comcast and goes somewhere different. Okay, down here, all right, we've got, so we're on another network over here, and then at some point we're going to get to this is probably the Google network. Okay, so what that trace route shows us is the journey that our data takes as it goes through those different networks. Okay, now what it also shows us, and we haven't really talked about this yet, is all of these numbers. Okay, so I've got a number, we can see that Google has a number, okay, and we can see that all of these different devices that we're traveling through, they've all got numbers too. Okay, so that number is called an IP address. Okay, and what the IP address does is it uniquely identifies a device on a network. Okay, so IP stands for Internet Protocol, and I'm sure you already know that an IP address, or a version 4 IP address, so IP version 4, okay, is made up of 4 parts. Okay, so it's made up of 4 different numbers. There we go, and each one of those numbers can be any number between 0 and 255. Okay, so an IP address is 32 bits. Okay, with each section being 8 bits each, which is why they can represent any number between 0 and 255. Okay, and hopefully you will know, or I'll tell you now. Okay, that IP address tells the computer and tells people a lot about where you are. Okay, because it's quite specifically tells people about the different kinds of network that you're on. Okay, so different countries, for example, have a range of IP addresses that are just available for them to allocate to people in their country. Okay, so your IP address can tell people the country where you live. Okay, the ISP that provides you with your access to the internet, and so there is lots of information that can be gained from your IP address. Okay, but the IP address is unique to you. It is your address on the internet that is unique to you.